Alright, good morning. Welcome to Advanced Java. Today, we're going to be doing a series of videos to get you started with the Advanced Java course. As you can see on the screen, I have Eclipse open, and I have several Java files open, and one of them is named Valencia Farmhouse Creating. I'm not going to go through all of these files yet because it's a series of videos I'll be doing to get you started with Advanced Java. This is the first of many videos that we will be doing this semester, and throughout this semester we will be creating a farm, a Valencia farm, haha, pun joke, and we will be adding animals and different things that these animals do to create a massive program that covers everything for the Advanced Java course. So let's go ahead and get started. This video is going to be focused on abstract classes and interfaces, and classes that implement interfaces and extend abstract classes. So where we left off from beginning Java is that we learned a little bit about using multiple inheritance, using multiple classes, and multiple interfaces. So this might be a review for some, or maybe a brand new topic for others. So let's take a look. The first thing I have open here is the interface, and let's not do that first. Let's do the animal one first. Okay. Now the animal one, I want to start here because this one is called an abstract class. Now, what an abstract class means is it's very similar to a concrete class. The only difference is that it could have abstract methods and concrete methods in the same class. Alright, as you can see here, we have some constructors and some methods. These are all concrete methods. But you notice in the bottom here, I have two abstract methods. Now, abstract methods are always public, and they have a semicolon at the end and have to be overridden. So when this class, when a concrete class extends this abstract class, then it has to implement these override these methods right here, these abstract methods. And some would say, why would you do that? You have methods already here. Can't you just make them concrete? Well, the reason being is that anyone who extends this animal class, for instance, I have a bird, they will all do different things. And the way we do it is that once this is overridden, these abstract methods, this will make any class that extends this abstract class override these methods. That means they have to have a noise method and they have to have an eat method. So all the classes remain uniform. So if you want to set up a contract for all of the classes that extend your animal class and make sure that they all have a noise method and make sure that they all have an eat method, this is the way to do it. That way you know for sure they always have these methods in there. They always have to be overridden by a class that extends this. So abstract methods are really cool and very useful, and like I said, they're always public. So you notice I didn't put a public in there. It's not necessary. I could have written public and it would have been fine, but you don't have to because it's always implied that it's public because it has to be overridden, so therefore it has to remain public. Okay. Now there are abstract methods, so I put a semicolon at the end. They don't have a body. Alright, so they don't have a body of this method. Now, abstract classes are defined by the abstract keyword right here. So you notice that a regular concrete class would just have public class animal, and abstract is right in the middle of it to become an abstract class. The other thing is that a class cannot be called abstract, at least I'm sorry, it cannot be called abstract unless it has one abstract method, at least one abstract method. So if all of this was concrete methods in here, I could not call this abstract class. Alright, it had to have had at least one abstract method in it to call it an abstract class. Alright, so that makes sense. Now, can an abstract class have nothing but abstract methods in it? Sure, it could just have 0 concrete methods in it and just have a bunch of abstract classes in it. So it's fine. You could have a bunch of abstract methods, but this abstract class gives you the ability of having both concrete and an abstract method in it, but it must have at least one for it to be called an abstract class. Okay, now, so this abstract class is called animal, and you notice that I have some data types here, and I have them private, and I have a constructor. These are things I'll be going over in other series of videos. For right now, this video is focused on abstract classes and interfaces. So right now, all you need to know is that it has an abstract method right here. This is how it's declared. They're always public. They have a semicolon at the end and have to be overridden by the concrete class that extends this class. Alright? A little lengthy, but it's very descriptive. Alright, so that's an abstract class. Alright, so once we have this abstract class that's here, let's take a look at the first one, which we started out, the Valencia Farmhouse creating. This is called an interface, and what an interface is, interfaces are 100% abstract classes. All methods are inherently abstract, public, and end with a semicolon. So all the methods in an interface are abstract. An interface cannot have any concrete methods in it. It has to have nothing but abstract methods in it. And of course, abstract methods are always public, and they end with a semicolon. All right. What you want to do with this is that our farmhouse is anyone who implements this interface, not extends, implements this interface, will have to meet the criteria of always having a building size method, an animal count method, a set animal method, and a get animal method. All right. So we want to make sure anyone who implements this interface always has these methods, and they're going to override them any way they want, but they have to have these methods in them. That's a good way of making sure that everyone stays uniform. Okay, I'm going to be using that word a little bit more. We're going to be talking about polymorphism and encapsulation later on, and this is a good way of starting out with that topic. So by the time we get to that topic, you'll have a better understanding of polymorphism and encapsulation, because this is all part of it right here. Okay, the same goes for these private variable names that I have here. Alright, so far this interface is declared as public interface instead of public class, public interface, and then the name. And you'll notice that this name right here has like an action word going on, and Valencia Farmhouse creating. And other interfaces I have down here are called flying and swimming. Alright, and you'll notice that these are all action words, you know. Nothing too exciting, flying and swimming, but most interfaces are all named by some kind of action word going on. Alright, that's just a standard. Do you have to do it that way? Would it not compile? No. Obviously, you know, there's no naming convention. Well, I mean, there is a naming convention, but there is no, it would not just say, okay, it doesn't compile because you didn't name the interface something I like as an action word. No, it will compile, but the naming standards are usually some kind of action word for a interface, and that's something I want you to follow as well. And the reason why we want you to follow all these little standards that we set up is that this is what happens in the industry, and the industry follows these practices. So at the same time, everyone is a little bit uniform on the naming convention. All right, that's why we use capital letters for classes, you know, and that's why we use action words for interfaces. So hopefully this was helpful, and you can now understand what an interface is in an abstract class. All right, hopefully you'll be able to make an abstract class and an interface. Okay. Now, an abstract class, once it's extended, there you go. Bird extends animal, and animal was the abstract class. This is a concrete class, bird, and it extends animal. Now this is the first concrete class to extend an abstract class. Therefore, it must implement all of the methods from animal, from the abstract class. Okay, if bird was actually an abstract class, it would not have to implement all the abstract methods. But bird is a concrete class. And we'll talk more about abstract classes, extending other abstract classes. But right now, we're going to focus on this video, a concrete class extending animal, which animal is an abstract class. Now this bird that extends animal, it has two constructors, which we'll go over in a later video. But you'll notice that these two methods right here, noise and eat. Noise and eat was an animal. They were the abstract methods. And you have these little triangles that tell you that it implements animal noise and implements animal.eat. It overrides those methods from animal, and it needs to. That's by contract. If you don't, if you actually, like, let's comment this out right here, you'll notice that it'll give you an error of some sort. Right here, see, bird. If you put your cursor over it, you notice that add unimplemented methods, meaning that it's missing a method, and it tells you right there that it's missing noise right there, animal.noise. So let's make it happy again. And there you go. It's all happy again. And I just did a little print statement out there that says bird noise and bird eating to keep in context with bird, so we know what method is being called at all times. Once this program gets large and huge, it'd be kind of hard to figure out which method's being called unless you put something significant in the method to figure out which one's being called. I could have put just a noise in there, but then I would have to remember which noise went with what, and that could be pretty hard. I guess I could have had a brr sound right here, and then a duck, which actually duck extends bird. I could have had a different sound in there that said, you know, quack quack or something, but I didn't do that right now. Okay, but for right now, you notice that this bird noise and this bird eating overrided animal. Okay, so that's good right there. Now, here is an example of the interface. Now, interface implementation. Now, we have two interfaces that I've talked about before. In this interface, you'll see that this is pretty simple. All it has is one abstract method, which is called fly. So, public interface flying, void fly. Once again, can we say it? It's public, right? Right? Okay, good. Because all abstract methods are public, and they have a semicolon at the end, and they have to be overridden. Okay? So, overloading and overriding is a topic that I kind of snuck in there with this lesson on interfaces and abstract classes. It's very important that you understand the difference, and we will go into that in another video, but for right now, overriding means simply taking this method and actually using the same name and performing some kind of action with the body of code. Alright, so if you don't understand what overriding is, that's what it is. It's just taking the exact same code that we have here and actually adding a body to this to have it perform something. So the interface right here just has fly, and this one has swim. Now, duck, which is another file I have here, notice that it overrid fly and swim because this one extends bird. Okay, so it's has it's extending the bird class right here, and it implements flying and swimming. So now you'll notice there's something different here. Duck extends bird and implements flying and swimming. So fly and swim are here because it implements both of these interfaces, and it has to override those methods, so it's there. But you'll notice that noise and eat are not here. Well, that's because bird extended animal, and since bird was the first concrete class, it had to override noise and eat. Okay, it had to. That's the contract of it. Now duck extends bird, which means it also extends animal, but since it's not the first concrete class to extend animal, it does not necessarily have to override the noise and eat methods. Okay, only bird did. Alright, so can we here? Yes, we could, but we're not going to do that. We're actually going to do that in a later example in the next video about overloading and overriding. But for right now, to meet the contract requirements of implementing an interface, we have to override fly and override swim. Alright, and this is how you do that. You could have, if duck didn't extend bird, you could just say duck implements flying and swimming. But duck is a bird actually, and I wanted to have the methods of bird, so it's going to extend bird and implements flying and swimming. Now you can see how it's coming all together right now in a little farm right here, because this has to do with object-oriented programming, and depending on how much you did in the beginning Java, you often wondered why everything had to be in separate classes. Well, this gives it more. It becomes more powerful when you're in separate classes. Your ability to reuse code becomes much greater, and you could see that with animal being very detailed and having some abstract methods, but very detailed, and then bird becoming a little bit smaller because it inherits this stuff from animal, and it adds a little bit more specific things here. But then duck, even more specific, becomes smaller and also more powerful because also it can implement flying and swimming, which an attribute of maybe not all birds have. Do ostriches fly? I'm not too sure. I forgot. I think ostriches cannot fly, and they're a bird, so they don't necessarily have to implement flying. I don't think they could swim either. So, you know, someone could have to actually look that up for me and see if that the ostriches can actually swim or fly. I don't think they can. But anyway, ducks can. They could fly and they could swim. So therefore, if these two were not already built in animal and not already in duck, then we would have had to build very, very lengthy codes for each one of them for languages such as C, which you would have had to have written so much more code. Here you have the ability to reuse it, and it's a little bit more cleaner and easier to understand. You could focus on different objects as we're going along. So there we go. That's how you implement, that's how you create an interface and implement an interface, create an abstract class, and extend an abstract class. And I hope these topics was very helpful to you. And I'll see you in the next video.